In this problem, two identical concave mirrors, each of focal length f, are facing each other as shown in the schematic diagram. The focal length f is much larger than the size of the mirrors. A glass slab of thickness T and relative and refractive index n0 is kept equidistant from the mirrors and perpendicular to the common principal axis. A monochromatic point light source S is embedded at the center of the slab on the principal axis as shown in the schematic diagram. For the image to be formed at S itself, which of the following distances between the two mirrors is or correct? So it is multiple correct answers. So we go with the options. But here already what we know. So in our discussions at class, what we know, two possibilities are there, so that light will come back to the same point from which it is started. So these are two mirrors. This is the source of light. When source of light falls normally onto the mirror, it retraces its path. Same here also, when it falls on the mirror at perpendicularly, it retraces its path back to the source. So this is one option we are having. So if the distance between the two mirrors is d, then if it is retracing its path, it is falling 90 degrees normally on the mirror, this source position will be at center of curvature. So the center of curvature distance from the pole P of the mirror, we know that is this is half of this one, d by 2 is equal to, this is a center of curvature. Center of curvature distance from the pole is 2f. So d must be of 4f distance. This is one possibility we know. Second possibility what we know is two mirrors are there. Both are having same focal length. This is the source of light. When source of light falls on the surface of the mirror and it is parallel to the principal axis and falls onto the other mirror and come back to the same position, then this distance is this is pole. This is this distance where the position where the source is there, that is principal focus. So this distance is focal length distance. But distance between the mirrors we have taken as d. Right? So this distance d by 2 is equal to focal length. That means d is equal to 2f. These are the two possibilities. Now in this problem, simply what they did is they placed a glass slab here. So whenever glass slab we place, normal shift will takes place. The normal shift once comes, see in the options, normal shift comes, this is the extra equation comes. So these two are correct, but let us do it. So option A, let us it is coming, this option, this possibility I will take now. So two mirrors are there. This is the poles of the mirrors. Pole to pole distance between the two mirrors is d, and a glass slab is placed here. Glass slab thickness is t. So exactly at the middle, t by 2 distance, the source is there. These are the two mirrors. So this is the pole of the mirror. Okay, now the light ray starts coming out and falls here. This is the normal. When denser to rarer going, it will be reflected like this and falls at 90 degrees. First option I am taking. It retraces its path, but here it appears for us it is coming to S1. This shift S1 is nothing but this is half of the, see, at the middle. So this is t by 2. Here this distance is t by 2 by n. So n naught. That is the shift. So whenever this happens, that is the the same thing will happen here also. Same thing will happen like this also. If this is the normal. So here also same thing will happen. This is normal incidence. So it retraces and it will be at a shift S1 when we see from the outside. So here this is the d by 2 distance, right, minus t by 2, and now see this distance I am taking, this distance is d by 2 minus t by 2. This is t by 2 distance. So this distance is d by 2 minus t by 2, but this shift is there now. This shift distance is plus t by 2 n naught. Then we will get the total distance from here to here, right? So that is that must be equal to 2f, radius of curvature. So what happens here, d by 2 I will take common, minus t by 2 I will take common, 1 minus 1 by n naught is equal to 2f. So d is equal to, this is 4f plus t into 1 minus 1 by n naught. So this is the distance between the two mirrors. So option A is correct. Option B also correct. Let us check. Option A is correct. Option B, second possibility. So second possibility, this is the mirror and this is also a mirror. The distance between the mirrors is d, and a glass slab is placed in between. So thickness is t. Exactly at the middle, S is there. Now same thing, light starts from this one. When it is falling here, this is the normal. So it will refract away from the normal. It falls and it normally goes, straightly goes parallel to the principal axis. So that is a normal incidence, no deviation in the slab. It falls here and it once again comes here. This is the normal. But the shift we can see here from outside is just this shift already we have calculated. The shift is t by 2 n naught, right? Whenever this happened, the distance is, the source is at a principal axis distance. So this distance is d by 2 minus T by 2 plus shift T by 2n naught. This is equal to the focal length. So then what happens? D by 2 will take common, T by 2 will take common. 1 minus 1 by n naught is equal to F. So from this, 2F is 2F plus T into 1 minus 1 by n naught is equal to D. So this answer comes. So option B also correct. So for question number 6, two options A and B both are correct. These two options are not possible because the shift like this formula comes when light ray is traveling from rarer to denser. So here light ray is traveling from denser to rarer. That's why these two options are ruled out. Only A and B correct answers.